in a silent vastness beyond Pluto, something is moving. A tiny speck of light is heading inward from the interstellar dark. It is clearly not from around here. It's difficult for us humans to fully comprehend the enormity of space. We are comfortable in our own cosmic neighborhood, the solar system, and are used to familiar faces like Jupiter, Mars, and of course, Earth. But out there, over 18 billion kilometers away from the Sun and beyond the heliopause, is the cold oblivion of interstellar space. The two Voyager probes are the only man-made objects ever to cross this threshold to this day. And until recently, only two known objects had ever made the opposite journey, passing from interstellar space into the solar system. Now we have a third visitor, and things are about to get even stranger. On July 1st, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, was performing its usual task of scanning the skies for moving objects. The Asteroid Terrestrial Impact Last Alert System consists of 4 telescopes across Chile, South Africa, and Hawaii. These telescopes each take around 800 images every night, and at the time of writing, they have registered 1,212 near-Earth objects. Initially labeled with the cryptic designation A11PL3Z, this object quickly drew attention as its orbit didn't match any known within our solar system. The next day, the International Astronomical Union confirmed what many had already begun to suspect. This was an interstellar object, only the third ever found. They officially named it 3I/ATLAS, where I stands for interstellar. Picture this: a chunk of rock and ice having traveled from another star, now passing through our cosmic neighborhood. For astronomers, it was a eureka moment. Larry Deno, one of the scientists behind the Atlas project, admitted that we don't know very much about this object. For experts, saying we don't know is both humbling and thrilling, because it means something truly new has been found. Everything in space is constantly in motion. Every object in the solar system rotates around the sun, because we are all trapped by its force of gravity. But when astronomers clocked the velocity of this new object, they were shocked. This was the fastest moving object ever detected in our solar system. The planet Earth orbits the sun at a speed of 30 kilometers per second. Mercury, at 0.4 astronomical units from the surface of the sun, has to orbit at a velocity of around 48 kilometers per second. The new object, discovered by Atlas, was moving at 58 kilometers per second, over 140,000 miles per hour relative to the sun. And at the time, it was still way out there just inside the orbit of Jupiter, about 4.5 astronomical units away from the sun. 3I/ATLAS is up to 12 miles wide, or 20 kilometers in diameter, according to initial reports, making it a massive cosmic iceberg. Based on brightness and assumed albedo values, the diameter of its nucleus is estimated between 5.6 to 11 kilometers across. This makes it an order of magnitude larger than Oumuamua and significantly bigger than Borisov's roughly 1 mile width. The Minor Planet Center reported tentative comet activity with a marginal coma and a short 3 arcsecond tail spanning over 25,000 kilometers. In other words, 3I/ATLAS isn't just a dead rock. It's already showing signs of life, like a comet waking up from solar heat. To understand how unusual 3I/ATLAS is, let's recall its two predecessors. Oumuamua, the Scout. In 2017, the Earth encountered a very weird object. The first was given the Hawaiian name Oumuamua, meaning scout or messenger from afar. This object was behaving too weird to be just another space rock. It was moving too fast, at 87 kilometers per second, when we first spotted it beyond Earth's orbit. What's really interesting is that before Oumuamua passed by the Earth, it flew so close to the Sun that it was actually inside the orbit of Mercury. And such a close encounter with a powerful force of gravity should have slowed the object down. But what we observed was that as Oumuamua moved away from the Sun, it actually accelerated out of the solar system. Oumuamua was a true mystery, small, oddly shaped, up to 400 meters across. For one, it's a very bright object, highly reflective, indicating that it's probably not made of rock. As we observed this light in the sky, it was pulsing from bright to dim and back again once every 7 hours. This led astronomers to the unlikely conclusion that the object was probably long and narrow like a cigar, and it was slowly tumbling end over end as it moved through space. The object had none of the comet-like visual characteristics. No coma, no tail, no visible outgassing of any kind. Yet, it behaved in a very comet-like fashion. People get hung up on the way Oumuamua looks, but it's actually the object's unexplained change in velocity that makes it so strange. At some points, it was changing direction by over 1,000 kilometers per day of non-gravitational acceleration. 2I/Borisov, the normal one. The second, discovered in 2019 by an amateur astronomer, was 2I/Borisov. Unlike Oumuamua, Borisov is definitely a comet. It looks like a comet, behaves like a comet, complete with a bright coma and tail. It was measured to fluctuate over 100 kilometers per day. Borisov displayed significant cometary activity, as its dust coma increased in size by around 1% per day, which indicated that it had been active for around 100 days prior to its first observations. It also had a longer tail, spanning 140,000 kilometers into space. Borisov contained water vapor, cyanide, carbon molecules, and large amounts of carbon monoxide. Now we have 3I/ATLAS, and there are 3 big differences between it and its interstellar siblings. Another contrast lies in its direction of travel. Oumuamua came from the direction of Vega. Borisov arrived from Cassiopeia. Both came in from above, from the northern sky, which is the general direction that the solar system is moving. So as much as they hit us, we also kind of ran into them. But Atlas is different. This one is a T-bone collision. It's coming from Sagittarius, roughly from the direction of the galactic center, coming in on that side angle in almost perfect alignment with all of the planets. The interstellar object is only 3 degrees off from the ecliptic plane. Space is 3-dimensional, and that object could have come from any direction. So to have something hit us almost perfectly side-on, it's a very big coincidence. Marshall Eubanks, the physicist tracking the object, notes that Atlas likely originated in the thin disk of the Milky Way, the same region where our Sun resides. But astronomers believe 3I/ATLAS came from the thick disk, that ancient region of space above and below the thin disk, where things hang out undisturbed for very long periods of time. This could make it as old as 7.66 billion years, nearly twice the age of our own planet. As we continued to observe 3I/ATLAS, things got stranger. Using 2 0.36-meter Las Cumbres observatory telescopes based in Hawaii, astronomers identified that the comet has a rotation period of around 29 hours. In a surprise to astronomers, 3I/ATLAS had a much flatter light curve than Oumuamua, and exhibited only 0.2 magnitude of brightness variation throughout the 29-hour period. When light from the sun hits that cloud of gas and dust around 3I/ATLAS, it scatters. Most objects in space have a mostly positive polarization, even interstellar objects. 2I/Borisov was positive, but 3I/ATLAS is negative. And not only that, it has the most extreme negative polarization of any object ever discovered. The coma was dominated by CO2 gas, with a ratio of CO2 to water at around 8:1. That's basically the opposite of what we are used to finding in comets. The presence of that much CO2 alone is pretty strange because it vastly outweighs the amount of water vapor, which is basically the opposite of an average comet. It's also full of metal, particularly nickel. A lot of comets have metal in their composition, but this only ever happens when the comet gets incredibly close to the sun, where there's enough heat to vaporize metal. 3I/ATLAS was releasing nickel when it was still out between Mars and Jupiter. When it was observed over the summer, astronomers detected a small amount of nickel but no iron, which is weird because nickel and iron come from the same place and are typically found together. The green glow and polarization. Let's begin with some recent images of 3I/ATLAS that were captured by astrophotographers in the remote desert of Namibia on the southern tip of Africa. This is already an incredibly dark place on Earth, but the photographers were able to take advantage of a lunar eclipse, where the shadow of the Earth blocked out any sunlight from reflecting off the moon, essentially creating the darkest sky possible, and therefore the clearest view into outer space. During this time, they could have pointed their cameras at anything, but they chose to locate 3I/ATLAS in their viewfinder, and what they saw was shocking. The object was glowing bright green in the night sky. Now, based on what we know about 3I/ATLAS, it should not be turning green. Or at least, there is no natural explanation right now for it to be green. You see, the prevailing theory among scientists and astronomers is that 3I/ATLAS is an interstellar comet. But the problem with 3I/ATLAS is that it keeps doing things that just don't make sense. For example, it's not actually unusual for a comet to turn green. And because this is pretty normal, we know a lot about the chemical process that creates the green color. It happens when carbon molecules in the coma are exposed to ultraviolet radiation from the sun. Specifically, this happens to diatomic carbon, or C2, which is just two carbon atoms that are bonded to each other. So, if 3I/ATLAS were a normal comet, it would have a lot of these carbon structures around its surface, and it would turn green in the sunlight. But we know from observations that were made over the summer, using pretty much every major telescope in existence, that 3I/ATLAS is actually deficient in these carbon chain molecules. It doesn't have any C2. And yet, it is clearly glowing green. So why is that happening? We don't know. Now, we also know that the coma surrounding 3I/ATLAS is filled with CO2, which is carbon bonded to oxygen atoms. And that is a totally different thing from C2. It does make the object incredibly bright, but that would not turn it green. There's another weird thing about the light from 3I/ATLAS. This has to do with the polarization of light. When light from the sun hits that cloud of gas and dust around 3I/ATLAS, it's going to scatter in different directions. But the direction that the light bounces is not random. It can tell us a lot about the material that the light is hitting. If the light scatters off to the side, at a right angle or perpendicular, then we call that positive polarization. If the light bounces straight back in a parallel direction, then we call that negative polarization. Most objects in space have a mostly positive polarization, even interstellar objects. 2I/Borisov was positive, but 3I/ATLAS is negative. And not only that, it has the most extreme negative polarization of any object ever discovered. That is pretty weird. And it's just one of the many oddities about 3I/ATLAS that tells us not all solar systems are the same. What we think is normal here would be weird somewhere else. And what's normal in a different star system is considered weird around here. In particular, the telescopes from Las Cumbres Observatory, LCO, are purpose-built to observe transient astronomical events, which can include events like comet outbursts and other changes in brightness. Using two 0.36-meter LCO telescopes based in Hawaii, astronomers scheduled a 1-hour observation sequence for 3I/ATLAS. Their goal was to identify a light curve for the comet, and to see whether it exhibited any rotational variability. Rotational variability means any kind of variation in brightness caused by the comet spinning on its rotational axis. Maybe it has an irregular shape and reflects light differently across its surface, or it has active regions that appear brighter to us when they face towards Earth. But by monitoring the changes in brightness over time, astronomers can identify repeating patterns which show that the comet has completed one cycle of rotation. Using the LCO telescopes, astronomers identified that the comet has a rotation period of around 29 hours. Though, like much of the information about 3I/ATLAS, further observations are needed to constrain this. In a surprise to astronomers, 3I/ATLAS had a much flatter light curve than Oumuamua, and exhibited only 0.2 magnitude of brightness variation throughout the 29-hour period. But there's also something weird happening with the way that 3I/ATLAS is moving through the solar system. What's interesting is the trajectory and velocity of 3I/ATLAS has remained almost perfectly consistent for the entire time that we've been observing it. Since the object was first spotted in early May up until right now in October, it has not sped up, slowed down, or changed direction by any meaningful amount. That might not sound weird, but if this were a comet, then it should be moving around a lot more. You see, comets heat up as they approach the sun, which causes them to melt, or technically to sublimate. And the release of that gas tends to push the comet around in space, like a thruster. So, a typical comet will change velocity and direction depending on what side is being exposed to the sun. We call that movement non-gravitational acceleration, or NGA. And we typically measure the average distance of variation that occurs in one day. As we've seen, 3I/ATLAS has been doing a lot of sublimating already, including a mini-tail that formed in the direction of the sun, which has now begun to evolve into a longer tail that is facing away from the sun. And yet, on a daily basis, the velocity and trajectory of 3I/ATLAS has only fluctuated by about 1.5 kilometers of NGA per day. Let's compare that with 2I/Borisov, the most normal of the interstellar trio. It was measured to fluctuate over 100 kilometers per day, about 100 times more movement on average than Atlas. Now, one potential explanation would be that Atlas is bigger and therefore harder to move. Makes sense. But we can bring in another point of comparison. This is Hale-Bopp. It's one of the biggest comets we've ever discovered in our solar system. At least as big as 3I/ATLAS. if not much bigger. We saw Hale-Bopp move around by an average of over 10 kilometers of NGA per day. Again, around 10 times more than ATLAS. So, even when compared to other interstellar objects, 3I/ATLAS is moving in a very strange way. It's holding such an unusually steady course that you could almost say it's intentional, as if it's being guided through the solar system. With only 2 previous interstellar visitors, every new one dramatically improves our understanding. Some scientists believe thousands may pass through the solar system unnoticed at any given time. Scientists inferred a density of just 0.001 interstellar objects per cubic astronomical unit of space, far smaller than previous estimates made when we discovered Oumuamua and Borisov. Studying 3I/ATLAS prepares us for the future. ESA's Comet Interceptor mission, launching in 2029, will wait in space for a suitable target, perhaps another interstellar visitor, and then race to meet it. Unfortunately, Atlas was discovered too late for any mission to reach it. This matters because interstellar objects are physical samples from other star systems. Without needing a spacecraft to travel for millennia, they may contain rare molecules, unusual isotopes, or other clues about how planets form around other stars. Should we panic about 3I/ATLAS? Absolutely not. Scientists determined from the beginning that 3I/ATLAS poses no direct threat to Earth. At its closest approach to our planet, it will be around 1.6 astronomical units away, over 600 times further than the Moon is from Earth. Instead, we should marvel at it. It's a reminder that matter, and perhaps even the seeds of life, can travel from star to star. Objects like this demand that we keep an open mind to the endless possibilities of the universe. A visitor from another star system will soon be gone, but the knowledge it brings will stay with us, helping us understand our place in a universe full of wanderers. The truth is out there, and for now, it's headed in our direction. In time, a lot of the mystery will be converted into knowledge. And that's why it's really important that we get to spend so much time studying 3I/ATLAS, because it means we get to eliminate a lot of these known unknowns. The most interesting stuff is still to come. Stay tuned,